So long division of polynomials can be a little tedious. Luckily, when your divisor is x plus or minus a number, there's an easier way to do it that we call synthetic division. Okay, and I've got an example here done by long division where we did 2x to the third minus 7x squared plus 0x plus 5 divided by x minus 3, and you can read through that. But if you look, it turns out the coefficients, there's this nice pattern. See, we're dividing by x minus 3. If we set that equal to 0, we have x equals 3. I think of it that way. I'm trying to see if 3 is a root if I have a remainder of 0 here. But if I divide by x minus 3, we start with a 3 for synthetic division. Then we can put the coefficients 2, negative 7, 0, 5. And the way synthetic division works, it's easiest to say by example. You drop the first number down. I drop the 2 down, and then I do 2 times 3 is 6, and then I add the columns. So negative 7 plus 6 is negative 1. Then I multiply times the 3. Negative 1 times 3 is negative 3. Then I add the columns. So when you're on the bottom row, you multiply by the number out here, and then you add the columns. So you drop the 2 to get started, and then 2 times 3 is 6. Add the columns. Negative 1 times 3 is negative 3. Add the columns. Negative 3 times 3 is negative 9. Add the columns, and I get negative 4. The last number turns out to be your remainder. And the 2, negative 1, 3 is exactly the coefficients of your quotient. Okay? So synthetic, turns out the nice pattern holds, and we can do this process called synthetic division. It's just the subtraction is always going to be these 2 terms at a time, and it just works out nicely with this pattern of synthetic division. So it's kind of hard to say what you do in general, but here it is written out. So we're dividing by x minus c. We put c on the outside, set our bar up, list all of the coefficients from a sub n all the way down to a sub 0, and this time you have to put zeros in if any of the coefficients are 0. If I don't have an x term showing in my polynomial, I got to throw a 0 in. So make sure you have them all there. You drop the first one down. It says here b sub n minus 1 will be a sub n. So these are the coefficients of your quotient, which if you're dividing into a degree n polynomial, your quotient will be degree n minus 1. So we could say this is a sub n, but you drop that one down to get this one, and then you do c times that to get this number. Whenever you're on the bottom, you do times c, then you add the columns, times c, add the columns. When you get to the end, you got your remainder, and these are the coefficients of your quotient. Okay? So let's do one by synthetic division here. We're going to do p of x is 4x to the 5th plus 7x to the 4th minus 6x to the 3rd plus x squared minus 8. We're going to divide it by x minus 2. So we're going to set it up. Be very careful here with the sign. If you divide by x minus 2, you put a 2 on the outside. Whatever you're dividing by here, the x plus or minus c, set it equal to 0 and put that number out here. Okay? So x minus 2 would be a factor. If x minus 2 were a factor, x equals 2 would be a 0 of the thing. So we put a 2 out here. And we've got our coefficients. 4x to the 5th, 7x to the 4th, negative 6x to the 3rd, 1x squared, 0x, very important, and negative 8. So I drop down the 4 to get started, and then I do 4 times 2 is 8, and then I add the column, I get 15. And then times 2 is 30, add the column, we get 24. 24 times 2 is 48, add the column, we get 49. 49 times 2 is 98. The numbers can start getting pretty big here. Add the column, we get 98. One more time, 98 times 2 is 196. Add the column, negative 8 plus 196 is 188. So 188 is my remainder, and these are the coefficients of my quotient. So my quotient is 4x to the 4th. We divide it into an x to the 5th here, so we get 4x to the 4th plus 15x to the 3rd plus 24x squared plus 49x plus 98. If you left out the 0 or something, you'd see you don't have the right number. It's got to be exactly the right number of coefficients here when we're done. So that's synthetic division. And just to mention again, some of these, like when you're doing WebAssign, you're doing homework, it may just say, do synthetic division, divide this out, and it'll just give you like one box, and it wants to know what is p of x divided by x minus 2. Well, it's my quotient plus my remainder over the divisor. Quotient plus remainder over the divisor if you have a single answer to the division. Okay, let's keep going a little bit more on this video. Let's see the principle of factorable polynomials. Given a polynomial of degree n greater than 1 with integer coefficients of positive and negative whole numbers or 0, and a lead coefficient of 1 or negative 1, the linear factors of the polynomial must be of the form x minus p, where p is a factor of the constant term. Okay? So if you multiply out a bunch of factors that look like this, x minus, x plus or minus something, the x's are going to go together to give you the leading term. So if you're going to get a 1 or a negative 1, they have to just be x. And then p's, those will all multiply out to give you the constant term. And you'll have all the middle terms as well, but it has to be that they're all x minus p, where p divides into the constant term. So that can help you guess factors sometimes. For instance, if you look at this polynomial, p of x is x to the third plus 3x squared minus 10x minus 24, if it has any solutions, any zeros, they have to divide 24, is what the previous slide was saying. If x minus c is going to be one of my factors and c is a 0, since my coefficient is 1 or negative 1 in the front, then my root here, 3, has to divide negative 24. And in fact it does, and it turns out that is one of the zeros, which we're going to show by factoring with synthetic division. Okay? So here's the use of division, and in particular synthetic division. It's harder to solve polynomials set equal to 0 when we go beyond degree 2. We can't just use the quadratic formula, so we need some other tricks here. If we can somehow figure out one of the zeros, like maybe look at a graph or something, we can then divide it out by synthetic division. So I'm going to divide x to the third plus 3x squared minus 10x minus 24 by x minus 3. So I put what turns out to be the 0, 3 out here, and do synthetic division. So we drop the 1 and then do 1 times 3 is 3, add the column, 3 plus 3 is 6. And then do 6 times 3 is 18, add the column. And we get 8. 8 times 3 is 24, add the column, and you get 0. If you know you've got a root here, your remainder has to be 0, so you know it worked out right. So what have we shown here? We've shown that we divided, got a remainder of 0. So our quotient is x squared plus 6x plus 8. And we have also factored the polynomial. We got a remainder of 0, so it's equal to our divisor, x minus 3 times our quotient. So p of x is x squared plus 6x plus 8 times x minus 3. So we've essentially factored by doing division. Okay? If we know one of the roots, we can divide by x minus c, and we will factor. And the other part is a quadratic. We can factor again, or if it didn't factor, we could use the quadratic formula, but it factors into x plus 2 times x plus 4. So we can completely factor the polynomial by first doing synthetic division and then factoring the quadratic quotient that we found.